You believe this is the peak of space exploration, but this telescope is already obsolete. A new eye is about to map the sky 100 times faster, hunt the invisible force tearing our universe apart, and it was built from a top-secret spy satellite. What will this panoramic eye reveal, and what will it tell us about the ultimate fate of everything? It started with a gift. Two pristine 2.4-meter mirrors, secretly built for a spy satellite, were handed to NASA. No price tag, no explanation. Just two of the most precisely machined objects on Earth sitting in a government warehouse. But the secret isn't the mirror. It's what's behind it. Behind that mirror is Roman's primary weapon, the Wide Field Instrument, an array of 18 state-of-the-art detectors forming a 300-megapixel camera for the cosmos. When Hubble takes an infrared picture, it captures a sliver of the sky, photographing a city one brick at a time. Roman doesn't photograph the brick. It photographs the entire city block in a single snapshot. But using a spy mirror came the dark side, a secret that almost killed the entire project. The result is a torrent of data so vast, it will map the universe 100 times faster than Hubble, the most efficient cosmic mapper ever built. And that speed is the only way to hunt the ghost that's destroying our universe. Right now, it's pushing everything away from everything else, faster and faster, every single second. This is dark energy, and if we never understand it, we will never know how our universe ends. So how do you hunt a ghost? You don't look for the ghost, you look for its footprints. As light from distant galaxies travels for billions of years, its path bends and distorts around the gravity of everything it passes. Roman's panoramic eye will survey hundreds of millions of galaxies, measuring that tiny distortion. A distortion that reveals the invisible web of dark matter holding the universe together, and the invisible energy tearing it apart. By mapping these footprints across the entire sky, Roman will build the largest three-dimensional map of the universe ever attempted. A map that forces a choice between two endings: a cold, empty death, or a violent, fiery one.
Roman isn't just looking at our ultimate end, it's looking for new beginnings. For decades, we've found planets by watching for a star's light to dip as a planet crosses in front. It works, but it's slow, and it only finds planets huddled close to their stars. The lost ones stay hidden. Roman uses something different. Something that feels like magic. As a foreground star drifts in front of a more distant one, its gravity acts like a lens, magnifying the background starlight. If that foreground star has a planet, its tiny gravity adds a second brief flash. This technique is sensitive enough to find planets as small as Mars. And here's where it gets strange. It doesn't even need a star. For the first time, we will find the rogue planets, worlds violently ejected from their home systems, wandering the cold, dark void of interstellar space, completely alone. Roman will discover thousands of them, turning our search for life from a hunt into a census.
A telescope that can solve the universe's greatest riddles seems like a guaranteed win. A perfect mission. Behind the scenes, something terrifying was happening. Remember that spy mirror? It came with a price. Adapting the military-grade optics for scientific use caused unexpected engineering failures and cost overruns. Then, the pandemic added $400 million overnight. The mission's price tag crossed $4 billion. The political threat became real. The Trump administration tried to cancel Roman 3 times, citing its budget and prioritizing the nearly finished James Webb Space Telescope. For years, it sat on the chopping block. Every morning, the engineers building this telescope came to work, not knowing if their project would survive the week. The team behind Roman wasn't just fighting the laws of physics. They were fighting a war against spreadsheets and political whims in Washington, D.C. Roman didn't just have to be revolutionary, it had to be a survivor, and its greatest weapon was yet to be revealed.
We've been detecting planets for decades, as graphs, as data points, but we've never truly seen one, a pale blue dot orbiting a distant sun. The problem has always been the star. A star is a billion times brighter than its planet. Trying to spot one next to the other is like trying to see a firefly hovering next to a searchlight from a mile away. Roman carries an instrument designed to do the impossible. Inside is a system of masks shaped like microscopic snowflakes that physically block the blinding light from the star's core. Then, two deformable mirrors ripple hundreds of times per second, actively canceling the scattered starlight, carving out a tiny, ultra-dark hole right where the star should be. The result is a coronagraph 100 to 1,000 times more powerful than anything in orbit today. It can isolate a planet that is a billion times fainter than its host star. This is a technology demonstrator, but what it demonstrates paves the way for the next generation of telescopes that will directly photograph Earth-like worlds and search their atmospheres for the chemical signatures of life.
All of this, the spy mirrors, the political battles, the ghost hunting maps, and rogue planet census, it all leads to this moment. The Nancy Grace Roman Space Telescope is no longer a concept on a slide. It's real. In May 2026, engineers completed the final inspection of the 7.9-foot primary mirror. The verdict? Perfect. The observatory is now being prepared for transport to Kennedy Space Center. The launch date is set, August 30th, 2026, 8 months ahead of schedule. Soon it will be loaded onto a Falcon Heavy. The countdown will echo across the Florida coast. 10, 9, 8. The engines ignite. After a million-mile journey, Roman reaches its final orbit, and for the first time, opens its panoramic eye. This isn't just another launch. It's the promise of a revolution that refused to die.
So how did humanity build a telescope that maps the universe 100 times faster? It was built through a secret alliance between spies and scientists. It was built with technology that can photograph a world a billion times fainter than its star. And it was built because a team of engineers refused to let a spreadsheet kill it. Roman moves us from speculation to statistics. It won't just suggest Earth-like planets are out there, it will give us the numbers to prove there are millions in our galaxy alone. It will rewrite our place in the cosmos. It replaces loneliness with context, revealing a universe far stranger and far more populated than we ever dared to imagine. Roman is looking outward, mapping billions of light years. But something much closer is already on its way. In 2029, an asteroid the size of the Empire State Building will pass closer to Earth than your own phone's satellite. We named it after the Egyptian god of chaos. And we still don't know exactly what happens next. If you want to be there when we find out, subscribe. It's free, and it might be the most important thing you do today. And if this video changed how you see the universe, the like button is right there.